Hello friends, in today's video we are going to discuss about one of the other application of stack by name recursion. In simple terms, we can define recursion as if a function calls itself, then we can define it as a recursion. So on that basis, I'll come up with a definition of a recursion. We can define recursion as the ability of a function to call itself. The ability of a function to call itself either directly or indirectly is termed as recursion. Now, what is the meaning of calling itself directly or indirectly means? If I want to put up what do you mean by calling directly and what do you mean by calling indirectly, the meaning of this is, assume that there is a function. Assume that there is a function by name f, and if this function f calls itself, then it is direct. Now, what do you mean by indirect? Indirect in the sense, assume that there is a function f, and this function, instead of calling itself, assume that it calls one more function by name p, and within this function p, this p function calls the actual function f. Then it is called as indirect recursion. Sometimes or some authors say that there are two types of recursion, namely direct recursion and indirect recursion. Based on that, I have framed up a definition for recursion as the ability of a function to call itself either directly or indirectly. It is termed as recursion. Note that whenever a function calls itself, as in this case or in this case, if a function repeatedly calls itself, then generally that particular function goes for an infinite loop. To avoid a recursive function going for an infinite loop, note that every recursive function should have a base case. It should have a base case or a base condition, and that base case or the base condition will generally be the first statement within the recursive function. So note that before this f function calls itself, before calling f, there should be a base case. There should be a base case. Even in this case also, there should be a base case. If there is no base case or if there is no base condition in case of a recursive function, then the recursive function will go for infinite times. It will be repeated infinitely. So this is about what do you mean by recursion. We'll start up with some small examples of recursion. The most common recursive function that we can think of is the factorial of a number. We know that if I want to in our high school definition, we might have found that, okay, in order to calculate the value of 5 factorial, we might have expressed the value of 5 factorial as 5 into 4 into 3 into 2 into 1, or rather than writing it as 5 into 4 into 3 into 2 into 1, I can just write it as 5 into, I know that the value of 4 into 3 into 2 into 1 is 4 factorial. So if you see, I have expressed 5 factorial in terms of 4 factorial. In more generic way, I can write n factorial as n into n minus 1 factorial. Now my objective is to find the factorial of a number. If you see that factorial is my objective, then I am expressing the value of a factorial of a number in terms of the factorial of the other number. So if I want to come up with a recursive definition, for the factorial, as I told earlier, every recursive definition or every recursive function should have a base case. Here I can take the base case as if n is equal to 1. If n is equal to 1, the factorial will be 1. So I can write the recursive definition for factorial as fact of n can be expressed as if n is equal to 1, factorial of 1 is 1, otherwise factorial of n can be expressed as n multiplied by fact of n minus 1. This is my recursive definition. With the help of the recursive definition, it is very easy to write the recursive function. We know that in case of the factorial of a number, my answer may be here in this case. I know the factorial, 5 factorial is 5 into 3 into 2 into 1. That is 3 2s are 6, 6 4s are 24, 24 5s are 120. My answer is an integer number. So if with the help of the recursive definition, if I am supposed to write a function, a factorial function, a recursive factorial function, then it can be written as this fact function should return an integer. So I am having the return type as int, and the argument to this factorial function is an integer number. I'll write that integer number as n. Now I'll go back to this recursive definition. It is quite easy to write my function because I know if n is equal to 1, I have to return 1. So if n is equal to 1, return 1. If not, what I am supposed to return? I am supposed to return n multiplied by fact of n minus 1. Hope this is clear. This is about what do you mean by recursion and how to write a simple recursive function to find the factorial of a number. Note that recursion is also an application of stack. Why it is an application of stack? Whenever a recursive function is being called for the execution, all the recursive function will be pushed on to stack. In the sense, in the primary memory, if you take the memory layout of a program, memory layout of a C program, the memory layout looks something like this. We can classify or we can divide the memory segment into 4 different things. The first thing we can call it as the text segment. The second one we can call it as a data segment. The third one we can call it as a stack segment. And finally we can have a heap region. Generally, this text segment will be used. All the executable instruction will constitute the text segment, and all the global and the static variable will take memory from the data segment, and all the local variables, the function call and the argument that is being passed to the function will take memory from the stack segment. And the heap segment is basically for a dynamic memory allocation. In the sense, if I want to allocate memory dynamically, that is, if I want to allocate memory during the runtime of the program or the execution time of the program, then we can opt for heap region. Now note that this stack memory segment is basically used. This is used for providing space for all local variables defined in the program, or it is also used for function calls. Now, as in case of a recursion, a function calls itself. So the memory region that will be utilized is the stack region. So we say that recursion is an application of a stack. Now, in this case, when we say that I want to execute fact of 5, fact of 5 is expressed as 5 into fact of 4. Now what happens is, whenever this fact of 5 is called for execution, fact of 5 will be pushed on to stack. Now what happens if this is your stack region, fact of 5 will not be executed directly. In turn, it will be pushed on to system stack. And as we have discussed earlier, that for all push and pop function in case of a stack, we use a reference called top of the stack. Here in case of the system stack, we call that top as the stack pointer. Note that stack pointer is nothing but the top of the stack, and it will be holding. It will be pointing to the topmost function that is present on the stack. Now in this case, when I call fact of 5 will be pushed on to stack. Now how to express fact of 5? Fact of 5 is expressed as 5 into fact of 4. Now fact of 4 is being called for execution. Now fact of 4 is pushed onto stack once again. Now how to express fact of 4? Fact of 4 is expressed as 4 into fact of 3. Now I am calling fact of 3. Now this fact of 3 will not be executed directly. In turn, it will be pushed onto stack, and I can express fact of 3 as 3 into fact of 2. Now this fact of 2 will be pushed onto stack. And it can be expressed as 2 into fact of 1. Now I call fact of 1. In the sense the fact of 1 is now pushed on to your stack. Now, while finding the value of fact of 1, if you see here, if n is equal to 1, it returns 1. Now what happens? This fact of 1 will be popped, and it returns 1. This 1 will be returned to this function. Now this 1 will be used by fact of 2. Now fact of 2 is 2 into 1. This was my 1 because my answer that I got from fact of 1 was 1. Now 2 into 1 is 2. That is my fact of 2. My fact of 2 will be popped, and it is going to provide a value for this fact of 3. Now this is 3 into 2 is 6. Now 6 will be returned by fact of 3. Now fact of 3 is a 6, and my fact of 4 is expressed as 4 into 6, which is 24. Now my fact of 5 is 5 into 24, which is 120. In the sense, whenever I call the fact function, note that, or in general, whenever I call a recursive function, the recursive function will be pushed onto stack until we get the base case. Now in this case, base case is if n is equal to 1. Once it encounters the base case, the recursive function will be popped from the stack. Is this clear? That's the reason why we say that recursion is an application. Recursion as an application of stack. Thank you.